My name is Gina. I am the Clean Program Coordinator for Climate Literacy and Energy Awareness Network, and it's really good to have our attendees here today. As you all know, we have an amazing webinar with Jessica Bean from the Understanding Global Change program. And she comes with an affiliation of UC Berkeley. And she's going to be talking about making climate change connections across the curriculum with clean resources and understanding global change, and talking about how to do this in the classroom and try to make it as interactive as possible. I'll be here monitoring the chat the entire time, so feel free to put things in the chat. I'll try to respond, and then we can save questions for the end. And without further ado, I'll let Jessica get started.
Great. Thank you so much, Gina. It's great to be here. Again, my name is Jessica Bean. I'm from the University of California at Berkeley within the Museum of Paleontology, and I run a project called Understanding Global Change. I have a background, I'm actually a trained scientist in my background, my educational background, but I've also been working in science education for most of my career. This project, Understanding Global Change, is actually the third generation website from the UCMP. Our first website you might have heard of is called Understanding Evolution. The second one was called Understanding Science, about the nature and process of science, and now Understanding Global Change. And I'm really going to talk about how do we make climate change connections across the curriculum using these Understanding Global Change resources today. And again, please feel free to reach out to me by email if you have any questions or thoughts after the webinar. That's our website address, and you can follow us on Twitter for some updates every now and then about the programs and what we're doing. Okay, so today I'm going to give you sort of an overview of the UGC project goals, and I'm going to also engage you in a little bit of discussion via the chat. So we can talk about sort of like why we would want to teach climate change in a more integrative, holistic way. And then I'm going to give you an overview of the UGC framework, Understanding Global Change framework, and the website. And then I'm going to show you some of the ways that you can engage students using these tools through games called Earth System Shuffle and Bingo. And we're just going to talk through those, and I'll show you how those work. And I do want to give a call out to my amazing collaborators and colleagues at HHMI Biointeractive, the California Science Project, BSCS, and National Geographic. Like I've been collaborating with a lot of different groups, and of course Clean, over many years now to support the use and integration of the Understanding Global Change resources with other programs and materials. So it's great to be here, and it's really wonderful to have all of these amazing collaborators on our project. So the first thing I'd like us to do is, again, start to think about how do we think about climate change, and then, how that also translates to how we teach it. So the first question I'd like you to approach in the chat, so just type in any answers, anything that comes to your mind, is how is climate change connected to our daily lives? So this should be hopefully a fairly accessible question for everyone. How does climate change affect our daily lives? So cost and availability to food is the first response that just came in. Yes. Heating and cooling. Yep. How we experience temperature and weather and the air we breathe, particulates, water issues. Okay, this is great. Any others you want to add? This is a good list. Fires, yes. So again, related to those water issues and weather and heating and cooling, any resources that cause positive or negative climate gases to change in our behaviors. And then Lori just said it's connected to everything. All right. And then someone else said shifting growing zones. Yes. So again, all of these things that are so interconnected and related to our daily lives. So I want us to think now about this next question. What do we teach that is not connected to climate change? Can we think of anything? What do we teach or what do we learn about that's not connected to climate change in some way? Not seeing anything in the chat yet. How to write stories. Okay. So how we write or learning how to write, but we could definitely be telling stories about climate change, right? Those are some of the stories that we hear, especially in the media. Some math. Okay, so maybe there's some math learning that we wouldn't always think of as directly connected to climate change, but we certainly use math to understand climate change, right? Anything else anyone can think of? I'm not seeing a lot of responses. Okay, so not too many things that we can think of. Space travel, okay, but certainly our understanding of climate and what we need to do space travel, to engage in space travel, is related to understanding climate change and the systems that we live in. Astrobiology, right? So that would be climates in other places, right? But very much a lot of that study is also comparing and understanding what we know about what's happening here and processes that happen on Earth compared to other places potentially. But yes, things like astrobiology are a little more removed from climate change. But these are good responses, and I think it's stretching our thinking a little bit. This is great. So then in thinking about the responses that we've given to these questions, does this align with how we teach about climate change? If it's connected to everything, if there's so much of what we do that we can connect to climate change, does the way that we teach climate change really align with the nature of climate change and what it is? And I'm reading, no way, we compartmentalize climate change teaching. Does anyone want to expand on that idea that was just put in the chat, that we compartmentalize? And someone else saying not yet, that this doesn't align. Someone else is saying no, subject matter as a unit or topic. Yeah, so we're approaching climate change as a unit, right? As a discrete thing. Anyone else have any thoughts? Short-term needs versus long-term consequences. This is a challenge. So thinking about, thinking about our world and how it's changing and connecting the short and the long term. I think that's what's being communicated there. Anything else? These are great responses. And again, that idea that like, if climate change is about everything and connects to everything, how should we be teaching about climate change, right? That's what I really wanted to get us to start thinking about. So thank you for your responses. That was really, really wonderful and useful to share your thoughts in this way. So the Understanding Global Change project really provides 3 primary tools that can help in breaking down these barriers to think about how we teach about climate change and why we teach about climate change in the way that we do. So the first is that we've created a conceptual framework for organizing the complexity and interconnectedness of climate change and broadly global change topics. So we're going to introduce that framework to you here today. The second is that they're actually tools that we've made for constructing visualizations or explanatory models of the Earth system to show how all of those things are interconnected, like to climate change. And then finally, templates that you could use for planning for integrating climate change and systems thinking into existing instructional units using clean resources. So how do you, again, take this perspective of climate change is related to everything, and how do I put that into my curriculum in a way where it's not just compartmentalized, it's not just that single unit, but it could actually be integrated throughout the year, throughout the learning that we're doing. So again, these are the primary tools. I'm going to introduce you to all of them today, at least briefly. And I just want to say that we, in the professional learning programs that I run, we take a deep dive into all of these. And a lot of the work that I do is working with school districts and programs, both formal and informal across the country, who really want to integrate this climate change perspective into the work that they do. So to do that, we need to use systems thinking, and systems, of course, is a part of NGSS. It's one of those cross-cutting concepts. And NGSS gives us this very nice, yet pretty simple definition of a system, that the system is an organized group of related objects or components. There are lots of definitions of systems and systems thinking. I'll just point that out, that if you go into the literature on this. But the thing that I want us to brainstorm now again about, and you can brainstorm on your own paper first, so take notes wherever is easiest for you, on the computer, on a scrap of paper, whatever, is think about, why is thinking about systems useful? And how do we know if our students are using systems thinking? What does that look like? Or what is that experience, what that students have? How do they experience that? So again, we're just going to take about 30 seconds for you to do that. So I'm going to pause really quickly. So write any ideas you have in response to those 2 questions. Doesn't have to be perfect. Any thoughts that you have that come to mind? So what I'd like for us to do now is to actually make our ideas visible and share them with each other. And we're going to use a Jamboard to do that. So we're going to take about 3 minutes, and you'll see on this Jamboard page will be these 2 different questions, and there's a side of the Jamboard for each question. And I just want you to think about that there are many ways to show your ideas. Like, so don't be shy. If you want to use a diagram, if you want to use words, whatever it is, place those ideas on the Jamboard. And I just want to show you, most of you have probably seen Jamboard, but just a quick review that frames or pages, you can click between pages up here, but the things you're probably going to use the most are sticky notes to write notes in, but you can also do things like import images and select things and move things around. So just so you know, these are the basic tools. And yes, and Gina just put the link to the Jamboard in the chat. Thank you so much, Gina. So let me know if you have any trouble accessing that. We're just going to use this first link. And again, there are many different ways to show your ideas, so don't feel shy. And I'm actually going to click over to the Jamboard now and see what's happening. Is everyone, people able to get in there? Don't see anyone joining yet. Let me make sure I'm on the right Jamboard page. Oh, there we go. I think I'm on the wrong one. There we are. All right. Yep. I see some ideas already appearing. So responses to why is thinking about systems useful? Because things are more complicated than linear connections. Okay, awesome. Why the world we live in is an interconnection. The why is that the world we live in is an interconnection of natural and human created systems. It makes us think about cause and effect and our actions and decisions. It's holistic, to see connections between concepts. I'm seeing some things. Inputs become outputs, become inputs. Okay, again, showing those like feedbacks and relationships, not necessarily being linear. Yep. And in response to the question, how do we know if our students are using systems thinking? Someone is saying they are seeing how parts are connected to a whole, and they identify the process of a system. Yes, processes of a system. Very good. Yeah. So again, that they're somehow able to really see and make those connections. And students need to go beyond thinking, let's see. Just going to move these over. Students need to go beyond thinking about individuals to how larger systems of energy production, transportation, urban design, economics, politics, legal, and the media, how all of that is interconnected. Yes, these are great responses. And how do we know students are using systems thinking? They are considering the big picture, using successive approximation, considering the delays, monitoring how things are changing over time. Also, that students are thinking beyond their own needs. Okay, interesting. So again, thinking about breaking down the boundaries of what we're considering and how we're considering it. Are they asking questions, getting confused, and thinking differently? This is great. And then someone also said that evidence of student learning could look like concept maps or descriptions of links between concepts. Okay, we're going to come back to that a lot. These are great ideas, and these all feed into, again, why we designed understanding global change in the way that we did. Are they coming up with innovative ideas to make connections between concepts and disciplines? Wonderful, yes. Are they considering circular nature of complex relationships, thinking about mental models, considering issues fully, thinking about long-term and short-term consequences? Wonderful. So thinking about different scales, different time periods, yep, different types of relationships. These are wonderful ideas. Thank you all so much. Oh, and there's some that are just covered up, so I'm going to just make sure we can see them all. Okay. If we want students to make connections, then we need to map those connections to each other. We create a puzzle, and the students' knowledge are the puzzle pieces, and they all connect. Wonderful. Okay, so I'm hearing a lot of the words like connections and puzzle and concept mapping, like all of these ideas. This is great. So I just want to say, like, this is part of the process that I went through when I was designing Understanding Global Change. Is I was like, what should this look like if we're really going to help students think about the larger, system that we live in, including climate change and all of what it's connected to? How are we going to do that? What is that going to look like? So this was great. Thank you so much for sharing all of your thoughts on the Jamboard. That worked really well. And so again, NGSS sort of does tell us, like, in terms of the progression through the grade levels, how students should probably be working with systems thinking. And as NGSS also points out, building models. So students can understand that the system interacts with other systems. They can use models to represent systems and their interactions, such as inputs and outputs. And in grades 9 through 12, students can investigate or analyze a system by defining its boundaries and initial conditions. And so again, if you look at that Appendix G about the cross-cutting concepts, you can see that progression of how students are expected to use systems and think about models throughout K through 12, which is great. And again, these things like modeling and feedbacks and relationships and cascading, cascades of changes, like all of these things are represented within the next generation science standards. So these are 2 examples of Earth system science standards from 5th grade and high school. So develop a model using an example to describe ways the geosphere, biosphere, hydrosphere, or atmosphere interact, or analyze geoscience data to make a claim that one change to Earth surface can create feedbacks that cause changes to other Earth systems. So again, this is all a part of what NGSS, the goals of NGSS and what they should do. And so all of this, again, was working to inform understanding global change. And I just want to say, too, that there's research out there in the systems thinking literature that indicates that using explicit systems language is actually really important, and providing students the opportunity to make those connections that all of you were talking about, in your responses in various contexts is also really important. So this paper by Gillison and al that came out in 2020 is actually a really good example of that. And they use certain even worksheets and assignments that they attach to the paper that they published that shows, like, what is that systems language, those system characteristics that we want to be using with students so they can really think about systems in a meaningful way, and then apply that systems thinking to new situations and new examples that they're working on. So again, using things like thinking about boundaries and components and interactions and inputs and outputs, and a lot, you were already using all of these terms in a lot of your responses. So feedbacks and dynamics and hierarchy, that these are things we should be explicit about, and students should be able to think about systems in this way, using this language. And that there are specific questions that we can be asking students to further their thinking about these specific systems characteristics. Like for boundaries, can you draw a boundary on the system? What belongs in the system and what's outside of the system? Hierarchy, which, what's a subsystem, or what's in, and how do you divide the system? So again, these are just really great guiding questions to help you think about how you would get students to get into that systems thinking mode. Because ultimately what we want is that students, as you were all saying earlier, are building connections and exploring how all of these things are interrelated, the physical, chemical, biological processes that are all related and connected to climate change. And I often come back to this meme that's been circulating now for a number of years about what's the difference between information and knowledge. That information can be discrete bits of information, but they aren't necessarily connected or useful. But to really build knowledge that's usable and transferable and that's going to serve a purpose, we want to connect the dots. We want learning to happen not just in isolation. And I'm seeing something in the chat about yes to the language and vocabulary of systems thinking. Yeah, that they're like, this is an important part of how we prepare students to think about systems. So awesome. And I just want to point out that Clean is an amazing resource for helping to do that, because what you have is an amazing database of resources about different topics, different angles on climate change and energy, and you can meld together those resources to help tell the story and build the connections over time. So that's one of the ways that I've used Clean in my own work with understanding global change to, again, build that knowledge and connect the dots over time. Okay. So I just gave you sort of that overview of what are our goals and why are we doing the work in the way that we're doing it. And so now I want to give you an introduction to the UGC framework and our website so that you know where to go to find some of these resources that we have developed around these goals and this vision of how students are going to think about systems and about climate change. So the Understanding Global Change website was really designed to help you discover why the climate environment changes, your place in the Earth system, and paths to a resilient future. But also ultimately, as you've all pointed out, to understand and visualize how everything is interconnected. Like that's the goal of the website, is to make that thinking and understanding visible of all of that interconnectedness. This is our homepage. When you arrive, the best thing to do is first go to this how to use this website button. And what you'll do first is get introduced to what we call the Earth scene. And this is the place where we can put all of our ideas. This is a template. Not to say that this is a template you should use for everything or all of the types of system models that you're using, but this is sort of a generic ocean to mountain scene that we built as a background, as a place where students can make their thinking visible and improve ideas over time. And this is a great starting point for thinking about the system and all the different parts of the world and the system connections. So there's a slideshow that you can watch, that you can click through, and I'm going to sort of walk you through that together today. But it'll again introduce you to this Earth scene, and then it'll walk you through the basics of our Understanding Global Change framework. So the framework is organized into three main sections. The first is that there is the Earth system. And these are the processes that shape our Earth through time that have been going on for millions, if not billions of years, right? So these are things like ocean circulation and the greenhouse effect and the water cycle and the carbon cycle, right? These are the fundamentals of how the Earth works. And what it's doing through time. Sorry, not sure why PowerPoint is doing an auto recovery right now. Okay. But then there are also measurable changes in that Earth system. So how do we know that the world is changing or that it's changed over time? How much and how fast does it change? These are the things we want to measure and monitor over time. Things like temperature, things like extinction or biodiversity or ocean acidification or snow and ice cover, right? Or precipitation. Like these are the things that change over time that tell us if the system is changing, if the water cycle is changing, or the greenhouse effect is changing, or ocean circulation is changing, right? These big systems that shape our Earth. And then finally, we can turn our attention to ultimate causes of change in the system. And we've divided those into both human and non-human causes. And we're very intentional about using human versus non-human and not using the word natural to sort of separate humans from the rest of the world. But the reality is that if you're looking at changes over the last 200 years, especially, like humans are a driving force in those changes, right? So we want to identify the human caused change, burning of fossil fuels, agricultural activities, all sorts of land use, urbanization, but that in deep time and over long periods of time, that we have to turn to non-human changes that are part of the system that can drive major global changes through Earth history. So things that, again, are not happening at levels that explain the amount of change that are happening today, like volcanism, but that in Earth's past have been very, very important, of course, in shaping the world that we live in. So things like volcanism or meteorite impacts or Milankovitch cycles, the tilt and the position of the Earth in space, right? So I'll review all these things in a little bit. But the idea is that there are both human and non-human causes of change. And we need to pay attention to both to understand the full extent of like why climate change today is cause for concern and why humans have again, there's something that we as humans can do about it, right? Based on how we interact with our Earth system. So what we've done is take those three categories and we've represented them as these concentric circles. So causes of change, which cause pressure on the Earth system, which can change the rate and magnitude of, again, things like the greenhouse effect or the water cycle. And then there are things that we measure in the system that are our data and our evidence for how and why the world is changing, how much and how fast. So we also divided, of course, the Earth system and the measurable changes into our four spheres: atmosphere, biosphere, hydrosphere, and geosphere. And then you can actually build up the complexity of this framework. And so that's what I'm going to step you through. And I just want to point out that all of these slides are available on our website. So if you go to What is Global Change and you go to What is Global Change 101, it will take you to two different slide decks, and I'm going to essentially show you a shortened version of that today, and we're going to walk through it together. But there are two different parts to this slide deck to unpack and fill in this framework to form what we call then the infographic with the full complexity of all of the different parts of the Earth that are represented in this framework. So I just want to reiterate that this is an introduction for adult learners, that this is not necessarily the way that I would introduce the framework to younger students moving forward. And there are many, many ways that you can do this with students. And I'm still learning, honestly, from my teacher colleagues as well about different ways that they're doing it in the classroom for different grade levels. So I would love to hear from you if you end up using it in a certain way with your students. This is a tool that can be used for both planning and thinking about how climate change and global change are connected to everything that you teach, but also something that, again, is student facing that can be used during instruction. And teachers have come back to me and indicated that just leaving the framework out in their classroom, whether it's on their own desk or up on the wall, really helps push their own thinking in supporting their systems thinking and getting students to think in this way as well. And I just, again, want to reiterate that learners, as indicated also by existing research on systems thinking, learners need opportunities to use systems thinking tools and language over time more than once to build their understanding and to make sure that these are skills that they have moving forward that they can apply to new situations. So again, the framework isn't something that you necessarily just introduce once or during one unit during the year, but the idea is that you come back to it and it's a tool that students become familiar with over time. Okay, so now we're going to go take a little bit of a deeper dive into this framework. And here's that concentric circle diagram that I showed you here before to represent sort of the different parts of the Earth and those causes and how the Earth system works and those measurable changes. And the way I often start this for adult learners is I start with the Earth system, how the Earth system works, because these are usually very familiar topics. So first of all, we have to think about the energy that drives our system, right? Where is that coming from? And so we represented the global energy budget in our framework as these primary things: the amount of sunlight that's absorbed and reflected, the amount of heat that's re-radiated from the surface of the Earth and in the atmosphere, and then of course there's Earth's internal heat from when the Earth formed and radioactive decay, right? And that heat drives a lot of the processes in the geosphere. So that's the global energy budget that drives our Earth system and how it's determined. And so on our Understanding Global Change website, we actually have pages of information about each of these topics. So you can learn more and take a deeper dive, or it's a great review. And sometimes, especially high school students, are often sent to some of these pages as a resource. And so again, you can learn more about what do we mean by absorption of sunlight, or what do we mean by re-radiation of heat, and how does that play into the Earth system? And these are just some of the supporting graphics that we have on those pages. So if we want to keep populating and filling out this framework with these ideas, we can think about what are the major processes that drive how our atmosphere and our hydrosphere function. So in our atmosphere, of course, we have the greenhouse effect and atmospheric circulation, which we also know is very much tied to ocean circulation patterns, and then of course our water cycle. So again, these are the fundamental processes that shape our atmosphere and our hydrosphere. And again, as I mentioned, we have these really great web pages that have lots of background information about each of these topics. So again, here's an example of a greenhouse effect graphic on our greenhouse effect page. Turning our attention to the biosphere and the geosphere, things like photosynthesis, respiration, of course, which are all product of evolution and species interactions. These are the fundamental biological processes that shape our Earth. Right. And the thing is, like, these are huge topics, right? We have an entire website just about evolution, but we need to represent this process as, again, a fundamental process of how the world works and how it's shaped over time. And then in the geosphere, of course, we have the plate tectonics and the rock cycle, which are very much interrelated. And we've also explicitly called out weathering here because of its role in the long-term carbon cycle. Again, really important process that's part of the rock cycle, but we did separate it out because of its role in the long-term carbon cycle and long-term changes in climate. Okay, then we can think about the elemental cycles that connect all of those spheres. So carbon, nitrogen, and phosphorus are usually the ones that we focus on, and especially in K-12 education, that cycle through our spheres. Of course, phosphorus doesn't really go into the atmosphere in the way that carbon and nitrogen does, but again, showing that all of these things are very much interconnected across different parts of the world. And then if you add up all of those processes that I just mentioned, like all those big processes, like the carbon cycle and atmospheric circulation and ocean circulation and evolution, these are the things that shape our climate and our ecosystems on Earth. So in this innermost ring on the how the Earth system works part of our framework, we just wrote those words climate and ecosystems, because those are the products of the sum of all of these processes that that occur on Earth. Okay. So that is our how the Earth system works summary, right? These are the fundamental processes that have shaped our world through time. Now let's turn our attention to what are the causes of change? What puts pressure on that Earth system to change it through time? And I'm going to start with these non-human causes again, because these are things that have been happening for a very long time, but they do not explain the rate and magnitude, of course, of the changes that we're experiencing today on Earth. So things like changes in solar radiation. Yes, we have 11-year sunspot cycles, but the amount of change in solar radiation does not explain the amount of warming that we are experiencing on Earth, right? Same thing with Earth's spin, tilt, and orbit. Those things are still changing, but they are not changing at a rate that could possibly explain or again, the amount of change and the amount of warming and the subsequent changes that we're experiencing. Things like meteorite impacts, luckily super rare, and we haven't had a big one recently, right? And then we've also called out other major tectonic and geosphere related processes that can cause major changes, like major events in volcanism or mountain building, which of course takes millions of years, and changes in the distribution of continents, again, something that happens over tens to millions of years, tens to hundreds of millions of years. So again, these are processes that, first of all, are either rare and fast, like a meteorite impact, and don't happen on a scale that causes major changes, right, all the time, or these are things that happen over much longer periods of time, like tens of thousands to hundreds of thousands, if not millions of years, that cannot explain the rate of change that's happening today, but they are happening, of course, all the time in the background in terms of our Earth history. So again, things like Milankovitch cycles and thinking about Earth spin, tilt, and orbit, right? We have a whole page just on that. And of course, on things like solar radiation. Here's the amount of solar radiation reaching the top of our atmosphere. But we continue to see our global surface temperatures rise. So again, solar radiation does go through these cycles, but it cannot explain this overall rise in temperature that we're experiencing on Earth. So we have to turn our attention to human causes of change. And I just want to point out that we actually left this framework, the way that we've written it, not just as what we think of as negative causes of change, things like burning of fossil fuels or pollution, but also language that is hopeful and could lead to resilience and solutions, things like renewable energy and innovation, and not just habitat loss, but also restoration, and not just deforestation, but also reforestation. So these are causes of change that could benefit humans and ecosystems, or they could harm humans and ecosystems. But again, they are some of the ultimate causes of global change, especially today and in the last 200 years. So we have content on our website about each of these topics, of course, about things like resource use and extraction, but then also about how do we mitigate and adapt to global change and climate change? What does that look like? So these are some of those topics that we address there. Okay. So then finally, we want to turn our attention to that innermost circle of our framework. So what are the measurable changes in the Earth system? Again, this is our data, this is our evidence. And so actually, if you're going to think about measurable changes, these are actually the basis. If you're doing phenomena-based learning for NGSS, this is the basis for great phenomena, right? That can be contextualized and localized for what are we measuring? What are we observing in particular parts of the Earth or in our local environments, right? So if you're looking for phenomena, we often turn teachers to this innermost circle to get ideas as a starting point for what are the things you might want to pay attention to. So for example, some of the things that we measure and monitor over time that tell us how much and how fast the world is changing are things like greenhouse gases or airborne particles, or these parameters that we measure as weather or extreme events that, of course, over long periods of time indicate changes in climate, but things like wind, clouds, precipitation, air and water temperature, ocean acidification, snow and ice cover, nutrient levels. So again, these are things that we measure and monitor over time to understand how much and how fast the world is changing. So for example, again, on our website, we have data sets that's showing, the changes in carbon dioxide in our atmosphere. How do we measure that over time? And what do we know about how it's changing today? Or those changes in global surface temperatures over time from long-term averages in the past, or changes in Arctic sea ice. So these are, again, things that we want to be measuring and monitoring to understand how the system is responding. If we look at our biosphere and our geosphere, we can look at things like, again, species ranges or life cycles and traits or extinction and biodiversity, or wildfires, which I think were also mentioned earlier. And in the geosphere, of course, things like soil quality, erosion, sedimentation, uplift and sinking of land, right? These are all processes related to the rock cycle that we can measure and monitor over time and can indicate various changes that are happening in our system. And then finally, we put humans on the outer causes of change, right? Because we are cause of change, but we also deal with the measurable changes themselves. And there are certain ones that most directly affect the quality of human life and our well-being, but also the well-being of the planet and our ecosystems. So things like air quality and water quality and food availability and our health and disease, and how humans are displaced. Where can we live? And where do we have the resources to survive? And again, that these things most directly affect our well-being and the well-being of the planet. So again, we are a cause of change, and we also deal with the consequences of change, whether they be good or bad, and how they affect these resources that we so need to survive, because we have a lot of decisions to make about how we're going to hopefully be resilient in the future and what the quality of human life will be for generations to come. Okay, so that was a lot of information. That was a very quick overview to what this framework looks like, and again, how we can build up this complexity. And again, this is a tool that teachers and students come back to over and over again in order to think about the system and the interconnectedness of the different parts of our world. So I just want to point out that on our website, you can actually use, again, what we call the infographic, which is this fully populated framework with all of those different, we call the icons, all those different topics. You can actually use that to navigate our site content. If you go to the Understanding Global Change infographic, this is a clickable infographic. So let's say I want to learn more about burning of fossil fuels. I can click on burning of fossil fuels. It'll take me to that page. And then you'll also see that there are all these other topics that are hyperlinked, of course, on that page. So if I want to learn more about temperature, I can click on temperature and it'll take me to that temperature page with that data and that information. There are lots of ways to navigate our site content. You can also see down here that the topics are divided into these major categories. So let's say I want to look at measurable changes, and I specifically am interested in things related to the biosphere. I could click that, and then all of these things related to the biosphere, like extinction and food and wildfire, all of those things will pop up. So again, lots of ways, dynamic ways to navigate the site content and explore these different concepts and think about all of the interconnections among them. I want to point out too that we have a version of this infographic that is in what we call everyday language. So this is just language that will make the infographic more accessible to all learners of any age. I've used this with middle school and high school and even beyond. But the idea is that instead of like using the four spheres like atmosphere and biosphere, we use words like air and life. Instead of, ocean circulation, it's like movement of water in the ocean, right? So again, using a few more words sometimes to explain these concepts to make it more accessible to learners of all ages. So we do have these versions available, and we have all of these versions available to download and to print. We have the complex versions and the everyday language versions, and we have the stripped down framework. And again, all of these are free and available online. We also have them in Spanish. And there are lots of ways that you can use this very simple version. So as I mentioned, there are a lot of different ways to get students into using the framework. And one of those ways is to sort of create like a word wall where you add the concepts over time as you're learning about different topics and different relationships among these topics. So you can build up the complexity of this graphic over time and just add the icons that are relevant to the learning that you're doing in the classroom. But again, ultimately, the idea is that students are going to be able to develop and articulate a system perspective and an understanding of all of these physical, chemical, biological processes that shape our climate and our ecosystems, and showing how they're all interrelated. So now ultimately, all right, so the framework really serves a few different things. First, it's a lens through which to see the world, right? To think about how all of these things exist on Earth and how they're interconnected. But it's also like a you are here map. It's like, what am I teaching today? What am I teaching tomorrow? And how might those things be interconnected? And another phrase that some of my colleagues have used, and the way that their students have described it, is it's sort of like having a mini textbook. Like if they become familiar with the framework, or they're building the framework up over time, that it's a reference tool. It's a way to come back to thinking about all these different topics and how they're interrelated. And I'm seeing a question. So someone's saying, how do students get into this? Are teachers expected to lecture, tell the students about all the elements and concepts you described to us? No, that is exact. So that's a really, really great question. So the idea is that I wanted you to become familiar with the framework as adult learners. So again, I'm sorry if I didn't emphasize that enough, but the idea is that I'm presenting this to you as a tool that you can then use with students. But the idea is that you create the need and the interest in the framework, and you build the framework potentially up over time with students by adding ideas, right? You don't show them the whole framework all at once to get them into it, because what's most important is that students are starting to think about connections among the different topics that you're teaching, right? So you don't need to show them this full complexity all at once. You can build it up slowly over time as students become familiar with different topics and thinking about how these things are organized and how they're related to each other. So I hope that answers your question in terms of like, no, the expectation is not that you would lecture or share this with them. Although for more advanced learners, so I should say for like undergraduate students and even some upper high school in certain cases, that it might be appropriate to give them this tool, to give them the slide deck, to show them what this is and how it can help you think about the world and how it's changing and how things are interconnected. But for most learners, for most K-12 learners, you want to ease them into this. And there are other ways that you can do this and use the icons and use the concepts. And I'm going to show you those in a second as well. So again, keep asking these questions. These are great questions. And thank you for using the chat. But again, the goal is that we're developing a way for students to articulate these connections and how these different parts of the world are related. So for example, if you're teaching photosynthesis or you're teaching species interactions, how is climate change connected? Can I go to this framework and can I say, okay, what else is related to photosynthesis? Well, it's actually related to greenhouse gases in the atmosphere. It's actually related to habitat loss and, deforestation or reforestation, and how species interact, right? And where that energy comes from that drives the biosphere. So like, these are the types of connections that we want to be able to make and use the framework to articulate explicitly, if that makes sense. So the idea is that I actually want you to practice that a little bit now, since again, I just given you a lot of information, but I want to give you a chance to actually explore the framework for yourself. So if you move forward into the frames on the Jamboard that you're on, find a frame, and then you can actually have a few people work on the same frame, but actually you might want to spread out because there are a lot of you here. So you can each take your own frame, or there are not as many of you as you there. Anyway, there are plenty of pages for everyone who's here. So each of you can take a frame and put your name on that frame and try to have, try to pick one icon, one topic that you teach as a starting point, and then draw arrows and explain how is that topic related to other topics related to climate. And other concepts that I teach. Thanks, Gina, for putting the Jamboard in the chat again. And again, if we had more time, if we were doing this in a professional learning setting, I would have you explain your connections. We would talk about them. We would really explore them. I just want to point out that this framework is going to look really small when you first get to these Jamboard pages, but you do have this zoom button in the upper left. So click on that. And you can go up to like 200. And if you zoom in, it'll be much easier to read and navigate on the Jamboard. So let us know in the chat if you're having any issues with that. And I'm going to click back to the Jamboard. So again, you can click forward on the Jamboard. All right, so again, you could click here and you could put your name in if you wanted to claim your page on the Jamboard, and then just start zooming in and exploring this framework. Think about what's one thing that I teach, and then how could I connect that to other topics on this framework? And if you have time, start to write out explanations of those connections. What does that mean? and draw some arrows and circle some of the topics that you see as related or interconnected. Let us know if you have any trouble getting into the Jamboard. Right, I see some pages being claimed. So again, we just want to give you a few minutes to explore this for yourself. And think about what are some of the connections that you can make to a particular topic that you teach. And please continue to put any questions or comments in the chat. And again, we're really doing this as a teacher-facing tool, right? This is you as instructors or providing some sort of formal or informal educational experience. How would you connect the dots between different topics that you're teaching? Right, I'm not seeing a ton of activity in Jamboard, but again, this is a tool that you can come back to if you want to use this Jamboard, make a copy of it for yourself. I do see some connections being made between things like burning of fossil fuels and renewable energy, greenhouse gases and the carbon cycle, innovation. Awesome. All right. Just give you a little bit more time, just draw some connections if you want to, and just again, explore that framework. So you can zoom in using this magnifying glass really far, and then you can navigate the screen and be able to read everything and draw if you want to using the pen tool. All right, see more connections being made. So ocean acidification to carbon cycle and wind and precipitation related to renewable energy. Wonderful. Yeah, so again, just starting to make these connections across different parts of the framework. And what I'm already seeing is connections between causes and those Earth systems and those measurable changes. That's great. Oh, and I see some more connections being made between species interactions and soil quality and biodiversity and invasive species and habitat loss and restoration. This is great. All right. Any others that I'm missing I haven't seen yet? Thank you for sharing. All right. Well, thank you all. Again, this is a resource that you can come back to and look at and think about. And again, we've been sort of approaching this from a teacher-facing perspective, right? So now I want to show you a little bit more about what this looks like with students, right? How do you use this tool with students? So, so again, this is, an example of sometimes what you get, or sometimes people just circle the whole thing and they're like, yep, it's all interconnected. But again, we want to be explicit. What are the connections that we want to make across different parts of this framework to what we teach and how we teach it? Because ultimately what we want to do is we want to move away from teaching these topics as discrete bits of information, and we want to build knowledge, right? We want people to understand how invasive species are related to species interactions, and how the ozone layer is connected to pollutants and waste, and how burning of fossil fuels and greenhouse gases and temperature and renewable energy are all interrelated, and we should not be teaching any of this in isolation. And so what we can do is we can take these topics, we can take these icons from our framework, and we can build models that represent our thinking and make that thinking visible, just in the way that all of you were describing at the beginning of our session together, right? Is like, what does it look like when students are understanding the system and thinking about the system and how it works? So we have created tools for making physical models with like actual physical materials, but also digital tools for creating models using this framework and using the icons. And so you can download these icons in both that original set and the everyday language and in Spanish. And we also have a Jamboard where you can get all of these pieces in one place. And of course, we also have this earth scene in both color and black and white at various sizes that you can use as a background, but you could also use any image that's relevant to the systems that you're studying, of course, as a background. And so a colleague of mine, Jen Pierce, she was featured on PBS NewsHour a number of years ago, actually using this with elementary school teachers and thinking about drawing the connections and understanding the greenhouse effect and renewable energy and human activities and how all of those things are interrelated. So we have this, this digital tool that's on our Understanding Global Change website. If you go to construct a model, and you can actually drag and drop the icons onto the scene and draw arrows and annotate them and explain, what do we mean by how are fossil fuels related to the greenhouse effect and how does that affect air temperature? You could explain that. Then you could save this and export it as a PowerPoint and edit it. And there are lots of different ways that you could use this tool. I'll just point out that this is a Clean selected tool. It's also part of the Clean collection. So there are more tips on teaching tips and information about the interactive online on the Clean website. And I should say that I've also used this just in terms of communicating about the science that I do as a scientist, right? So I've actually studied ocean acidification. And a lot of what I do is trying to understand how ocean acidification affects the life cycles and traits of marine organisms, specifically invertebrates, things like snails and bryozoans and other animals that calcify, right? That have those skeletons. Calcium carbonate skeletons. So what we know is that a third of the greenhouse gases that we put in our atmosphere are absorbed by our ocean. And that causes ocean acidification. And the sources of that CO2, of that carbon dioxide, is things like agricultural activities and burning of fossil fuels and deforestation and pollutants and waste. And of course, when I'm studying these things, it's actually a double whammy because we have the acidification itself, the drop in pH in the oceans, but we also have warming of our atmosphere and in turn warming of our oceans. So we're dealing with organisms that have two very important stressors that are affecting their life cycles. And so those things can affect when their life cycles and traits are affected and these organisms are stressed, it can affect species populations and of course, overall productivity and biomass and where these species can live, their ranges and the interactions that they have. So again, this is actually just a pretty simple example of how you can start to expand out this model to show the system and how these different parts are interconnected from, human activities on land and into the atmosphere and into the ocean and our biosphere. So the tool has these different options to export. You can export it with the connections and the arrows. You can connect it as a fill, or you can export it as a fill in the blank with or without arrows. And then also these handouts that you can use for all sorts of types of assessments. And again, you can change the background as well in the tool, because again, you might not want to use that earth scene, and that's okay. So here's an example of a student model in progress about parts of the San Francisco Bay and the way that they are annotating it and showing connections between different topics related to sea level rise and urbanization and pollutants and waste. So again, on our pages, on some of our pages, we have examples of models, like here's an example greenhouse effect model. And then in our teaching resources, we have all of these different tools like the infographic and the icons and the earth scene, and also tips for, again, how do you get your students into this? What does this look like in the classroom? How should you be constructing models with them? How do you support that? And again, it should be an iterative process. It shouldn't be that students make one model and then they're done with it, but it's how is their understanding changing over time? How is their understanding of the system or the boundaries of the system and the inputs and the outputs? How is that changing as they learn more? And again, thinking about how do we find good phenomena for our students to investigate about their local environment. And the infographic provides a really great tool for thinking about what's measurable and observable, and where do we start if we're designing phenomena-based instruction. We also have an example unit and also some example units that were developed by teachers on our website. This sea level rise unit includes a lot of clean resources and was piloted by a large group of teachers in the San Francisco Bay Area, and has also been used actually on both coasts, both in Maryland and in California, with over 1,000 students. But again, using the Understanding Global Change modeling tools are a part of this unit that was constructed using a lot of clean resources that are linked in a coherent sequence, so that you're building students' understanding of sea level rise, the causes and consequences, and also mitigation and adaptation in response to sea level rise over time. And by the end of the unit, this is kind of an exemplar model of what students might create to show all of the relationships, again, of like activities on land that humans do connected to the atmosphere, connected to the hydrosphere and sea level rise, and how that again affects humans, and how habitat restoration can be one of those ways that we can be resilient in the face of sea level rise. So again, this is just an example of a model related to a unit. And so a lot of the work that we do in our professional learning is to step through what we call the Understanding Global Change Planning Guide to either revise existing units that you already have, whether, regardless of topic, and we use units from across the curriculum, chemistry, physics, biology, history, social science. Even now we're in a partnership that I'll talk about in just a second with a history social science project. But we start with identifying standards. We think about what's the climate change and the global change phenomenon that we want to drive student learning. We construct models using UGC like this one to help inform, like, okay, what are the big ideas that students are going to understand by the end of this unit? And how are we going to make sure that they can make those connections? Thinking about the scope and sequence and the resources and the data sets that we're going to use in this unit. And then thinking about applying that systems perspective across the curriculum to other units, right, over the course of a year. And how is this going to inform the next unit that we do? And how is this going to connect to things that we've already done, potentially? So this is again, a planning guide that it's on our website, and we use it in lots of different forms with lots of different grade levels, all the way from kindergarten all the way through undergraduate education. But this has been a really great tool to go hand in hand with the Understanding Global Change framework for identifying those system connections and building them into a scope and sequence of instruction. So as I've alluded to, we have a lot of professional learning communities that are doing this kind of work and building instructional units over time about various phenomena. A lot of them are based in California. So of course, things like wildfires and changes in populations of things like salmon and starfish are some of the main topics that have been used. And we're really grateful to some of our partners like at the Lawrence Hall of Science and the California Science Project and NOAA BWET for supporting and funding a lot of this work that we do across K-12 in helping teachers build out these climate connections into units across the curriculum. Okay, so we are really out of time. Time went really quickly. So I just want to point out that there are a couple of other ways that you can have students be using these tools and working in groups. Things like creating group models and connecting to different key concepts and working together and sort of negotiating. We call that Earth System Shuffle, where people are connecting different topics to, across the curriculum, and as they learn more, how they're expanding models and adding to models. And one of the other things, which I think is super silly, but it's actually pretty amazing in the way that it gets students and teachers to stretch their thinking, is in playing what we call Earth System Bingo. So creating a bingo card using the icons, and then looking at a data set or looking at a video or some information and thinking about what are the connections I can make across the Earth system, and then having to explain those connections as part of getting bingo and winning the game, right? So this is something that we've actually used across K-12 with students and teachers in professional learning. So again, I've been super grateful to all of the teachers and all the colleagues who have informed this work. Again, I've introduced you today to just a very brief overview to these three main tools: the conceptual framework and the infographic for organizing all of these topics, the tools for constructing models, and then of course that template for integrating and planning instruction using clean resources and the modeling or system modeling. Just a really quick shout out that we're also doing some work now with the History Social Science project that's in California that's funded by the Library of Congress. We have a few more spots available actually in this PLC. The first date has already happened, but we have our next meeting coming up. So if you are interested, I will put this link in the chat really quickly. If you want to learn more. And it is California focused, but I think it is broadly relevant to anyone teaching climate change or interested in teaching at the interface of history, social science, and science instruction. And with that, I just want to say thank you to all of my collaborators and people who have informed this work. And please reach out if you have any questions. Thank you for your time.